Hurricanes form over warm ocean water when large masses of air begin to rotate. For such a storm to develop, the water must be at least about 26 degrees Celsius warm. Because of this heat, water evaporates and moist air rises upward. In higher layers of the atmosphere, this air cools again, the water vapor turns into clouds, and heat is released in the process. This released heat causes even more air to rise. A self-reinforcing cycle begins. While the warm air continues to rise, new moist air flows in from below. Due to the rotation of the Earth, known as the Coriolis force, the entire system starts to spin. On the northern half of the Earth, a hurricane rotates counterclockwise, while on the southern half, it spins clockwise. When the vortex becomes stronger and a clear center with very low air pressure forms, this is called the eye of the storm. Around this eye, the most violent winds and rainstorms occur. A hurricane can grow hundreds of kilometers wide and reach wind speeds of over 200 kilometers per hour. When the storm reaches land, it loses its energy source, the warm ocean water, and gradually weakens. However, it often still brings enormous rainfall, storm surges, and flooding. Climate change has a major impact on the strength and frequency of such storms. As the Earth continues to warm, ocean temperatures also rise. Warmer water means more energy for a hurricane, which leads to stronger and more dangerous storms on average. In addition, global warming causes sea levels to rise. When a hurricane then hits land, severe flooding becomes more likely because the water stands higher. The amount of rainfall also increases because warm air can hold more moisture. One can therefore say that climate change acts like an amplifier. It does not necessarily create more hurricanes, but it makes them significantly stronger. The strength of a hurricane depends on several factors. The most important one is the temperature of the ocean water, because it provides the storm with its energy. The warmer and deeper the water, the more energy is available. The humidity in the air also plays a role. Dry air can slow down the formation of clouds. It is also crucial how evenly the winds blow at different heights. When the winds vary too much in strength or direction, the hurricane is pulled apart and weakens. A low air pressure in the center of the storm and a slow movement over the ocean allow it to grow stronger. To determine the strength of a hurricane, scientists use various measuring methods. Satellites observe the storm from space, showing its size, its movement, and the eye of the hurricane. Special aircraft called hurricane hunters fly directly into the storm and measure wind speed, air pressure, temperature, and humidity. In addition, there are floating measurement buoys on the ocean that record wind and wave height. All of this data is then analyzed by computers. Based on the measured wind speed, the hurricane is classified on what is called the Saffir-Simpson scale. This scale has 5 levels. A hurricane of the first category has strong but not yet destructive winds. A storm of the second category can already tear off roofs and uproot trees. From the third category onward, it is called a major hurricane, capable of causing severe damage. A fourth category hurricane leads to catastrophic devastation, destroying many houses. The fifth category is the highest level. The winds are extremely strong, and entire regions can become uninhabitable. This classification helps meteorologists to warn people early and to plan evacuations. In summary, a hurricane forms from warm, moist air over tropical seas, is set in motion by the rotation of the Earth, and is powered by the energy of warm water. Its strength depends on ocean temperature, air humidity, wind conditions, and air pressure. Because of climate change, the oceans are getting warmer and the storms more intense. A powerful example of how closely the forces of nature are connected.